Welcome to AI Frontiers, where we explore the cutting-edge research shaping our technological future. Today we're diving into revolutionary breakthroughs from computer science machine learning, featuring 17 groundbreaking papers from July 19, 2025. These discoveries span from predictive healthcare systems to advanced fraud detection, representing the convergence of theoretical advances with real-world applications that will define tomorrow's intelligent systems. Picture this. Somewhere in a hospital intensive care unit right now, an artificial intelligence system is quietly watching chest x-rays and patient monitors, predicting which patients will develop life-threatening complications 12 hours before human doctors can even see the warning signs. This revolutionary shift from reactive to proactive healthcare isn't science fiction. It's happening today thanks to groundbreaking AI research that's transforming how we approach medical care and patient monitoring. What if a single day's research could revolutionize everything from fraud detection to automated mathematics, from social media platforms handling billions of connections to AI systems that never forget what they've learned? Today's exploration covers 17 remarkable papers that serve as blueprints for intelligent systems touching every aspect of our lives. These aren't just academic exercises, they represent the foundation for tomorrow's technological revolution. Computer science machine learning, known in academic circles as CS.LG, represents the central nervous system of our digital age. Think of it as a vast interconnected ecosystem, where different algorithmic species evolve and adapt to solve humanity's most pressing challenges. This interdisciplinary tapestry draws from statistics, mathematics, computer science, and cognitive science, creating algorithms that learn to recognize patterns and make predictions without being explicitly programmed for every scenario. This field powers everything from movie recommendation systems to medical diagnostic tools with superhuman accuracy. The first major theme emerging from these papers revolves around multimodal learning and temporal modeling. Researchers are moving beyond analyzing single types of data in isolation, like detectives who weave together multiple sources of evidence over time to solve complex cases. Aurora and colleagues exemplify this approach by combining chest X-ray images with clinical data like vital signs and laboratory values to predict future medical conditions. This represents a fundamental shift from traditional single-modality approaches toward more holistic systems that process and integrate diverse information sources, much like human experts do when making complex decisions. The second prominent theme focuses on robustness and reliability in machine learning systems. As these systems become more powerful and are deployed in high-stakes applications, researchers are grappling with a critical question: how do we make AI systems more dependable and trustworthy? The work on Rashomon partial dependence profiles tackles the problem of explanation uncertainty, recognizing that relying on a single best model can be misleading. Similarly, research on rational activations explores the delicate balance between model expressivity and training stability. It's like walking a tightrope between power and stability. Too much flexibility and the system becomes unpredictable. Too little and it can't handle complex real-world scenarios. The third significant theme centers on efficiency and scalability, addressing the growing computational demands of modern AI systems. As models become more complex and data volumes expand exponentially, researchers are increasingly focused on developing more efficient algorithms and architectures. The RecAD framework addresses computational efficiency in cybersecurity applications, while work on inverse Hessian vector products focuses on making training data attribution more computationally tractable. Think of this as the engineering challenge of building skyscrapers. As we reach for greater heights in AI capability, we need increasingly sophisticated foundations. The fourth theme involves continual and lifelong learning, addressing how systems can learn new things without forgetting what they already know. The GRID framework addresses this challenge in large language models, exploring how systems can maintain and build upon their knowledge over time, much like humans accumulate expertise throughout their careers. Among these 17 papers, several present findings that could significantly reshape machine learning research and applications. First, Patrick Rasinger and colleagues provide the first theoretical guarantee that a specific mutual information skill learning method can provably recover true underlying features of an environment, like finally having mathematical proof that a map-making algorithm will create accurate maps. Second, Mehak Arora's team demonstrates their CXR-TFT system can predict abnormal chest X-ray findings up to 12 hours before they become radiographically evident. Third, Yiding Song's investigation reveals that directionality in neural networks can be induced through pruning techniques rather than being hardwired. Fourth, Claudio Giusti's team achieves remarkable fraud detection performance with an F1-SCORE of 93.14% and recall of 90.18%, potentially saving billions in fraudulent transactions. For our paper of the day, let's dive deep into the remarkable work by Mehak Arora and colleagues on CXR-TFT, multimodal temporal fusion transformer for predicting chest X-ray trajectories. This research represents a quantum leap in predictive healthcare AI, addressing one of the most challenging problems in intensive care medicine, predicting the evolution of patient conditions before they become clinically apparent. The researchers recognized a fundamental limitation in current medical AI systems, which typically analyze medical images in isolation without considering the rich temporal context provided by continuous patient monitoring data. Their validation involved 20,000 ICU patients, providing substantial statistical power and confidence in the groundbreaking results. The core innovation of CXR-TFT lies in its sophisticated approach to multimodal temporal fusion. The system creates a unified framework that can reason about both sparse, high-quality information from chest X-rays and continuous high-frequency data from patient monitoring systems. The technical approach involves several sophisticated components working in concert. First, a vision encoder extracts meaningful representations from chest X-ray images, creating dense embedding vectors that capture essential visual information. These embeddings are then temporally aligned with hourly clinical data through careful interpolation techniques that account for irregular timing of chest X-ray acquisitions. The heart of the system is a transformer model that learns to predict future chest X-ray embeddings based on historical sequences of both imaging and clinical data, enabling unified reasoning across multiple data streams. What makes this approach conceptually powerful is that rather than trying to predict specific clinical outcomes directly, the system predicts the evolution of chest X-ray appearance itself. This is brilliant because chest X-rays serve as a comprehensive window into multiple organ systems and pathological processes. The key finding that the system can predict abnormal chest X-ray findings up to 12 hours before they become radiographically evident represents a genuine breakthrough in predictive healthcare. This 12-hour window is clinically transformative because it provides sufficient time for medical teams to implement interventions that could prevent or mitigate serious complications. In intensive care settings, conditions like acute respiratory distress syndrome can develop rapidly with high mortality rates, particularly when diagnosis and treatment are delayed. The system's whole patient approach, integrating multiple data streams, aligns with how experienced clinicians think about patient care, making it more likely to be accepted and effectively utilized in clinical practice, providing a template for future medical AI integration. Looking toward the future, these research directions point towards several exciting possibilities that could reshape our technological landscape. Think of current AI research as planting seeds in a vast garden. Some will grow into towering trees, providing shade for entire ecosystems of applications. The scalability breakthroughs we're seeing, like the ability to process graphs with 100 billion edges, suggest we're approaching a world where data size is no longer a limiting factor for AI applications. The advances in multimodal and temporal learning point toward AI systems that understand the world more like humans do, not as isolated snapshots, but as rich, interconnected experiences that unfold over time. The progress in continual learning suggests we're moving toward AI systems that can truly grow and adapt throughout their operational lives, accumulating wisdom rather than being static tools. The emphasis on interpretability research indicates a future where AI systems won't just be powerful black boxes, but transparent partners that can explain their reasoning, enabling new forms of human-AI collaboration. Today's journey through the frontiers of machine learning research reveals a field simultaneously reaching remarkable maturity while opening entirely new horizons of possibility. We've seen how AI systems can now predict medical emergencies before they happen, process datasets of unprecedented scale, and learn continuously without forgetting past experiences. These aren't just incremental improvements, they represent fundamental advances in our ability to create intelligent systems that genuinely augment human capabilities. The theoretical breakthroughs provide mathematical foundations for the next generation of AI systems, while practical applications demonstrate immediate real-world impact. From fraud detection systems that could save billions of dollars to medical AI that could save countless lives, these advances paint a picture of a future where AI becomes an increasingly powerful and reliable partner in solving humanity's greatest challenges. The diversity of approaches shows that machine learning research is exploring multiple avenues simultaneously, each contributing unique insights to our growing understanding of intelligence itself. This comprehensive analysis was created through AI synthesis, using Claude Sonnet 4 from Anthropic, with text-to-speech synthesis powered by DeepGram technology and image generation through OpenAI systems. While this content has undergone human expert review, we acknowledge the potential for oversights in interpreting complex research. All original references from the archive preprint server are provided for verification, ensuring you can explore the source material directly. This transparent approach allows you to dive deeper into the technical details and form your own understanding of these groundbreaking discoveries. As we stand at this exciting juncture in AI development, I encourage you to dig deeper into these papers yourself, explore the code repositories that many researchers make available, and think about how these advances might apply to challenges in your own field. The future of AI isn't just being written by researchers in academic labs, it's being shaped by everyone who engages with these ideas and finds new ways to apply them. Share your thoughts about today's discoveries online, join conversations in AI communities, and consider how you might contribute to this remarkable journey. Your unique perspectives could spark the next breakthrough. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this IPO uses archivepreprinserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.